Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 56, merge intervals. This problem description tells us that we're given an array of intervals where intervals, where each element in the intervals list has a start and end value, and we want to merge all overlapping intervals and return an array of the non-overlapping intervals that cover all the intervals in the input. Okay, so here are two examples. In the first example, we can see that we have this input over here and we return this output over here. And we can see here, we merge these two intervals, 1, 3, and 2, and 6, because they overlap. And when it comes to these two intervals over here, 8, 10, and 15, 18, they don't overlap. So we can just insert them, append them to our output list as they are, and then we return this list over here. And then we have another example over here, and this example is really to illustrate that overlapping intervals are considered overlapping even if the end and start times touch. So even if they are touching each other, they're still considered overlapping. So in this example, 1, 4, and 4, 5, they are touching each other, and that is still considered overlapping. So the output is 1 and 5. So really the way, the core logic, the core kind of problem that we need to solve is detecting when two intervals are overlapping. And when, what is the case that we can consider and we can ascertain that two intervals are overlapping? Well, it's when the start interval, the start value of an interval is less than or equal to the end value of the interval that came before it. So in this example, 2 is less than 3. Therefore, these two intervals we know are overlapping. In this example here, 4 is equal to the 4 that comes from the ending value of the interval before it. So these intervals are also overlapping. So that's kind of the logic. We need to check that the start is less than or equal to the end. That's the core logic to solve this problem. Once we understand that, it's fairly simple to really go through the code. The first thing we really want to do is go through each element in the list and say, if we'll have a new merge list, and we'll put each element from our intervals, each interval into our new merge list. However, if they are overlapping, so if we detect an overlapping interval, we'll merge them together before we append them to our new merged list, and then all we have to do is return our merged list, and that's all our code is going to actually do. So fairly straightforward. Let's get to coding. So the first thing we want to do is just to make our lives easier, because it would be pretty hard to solve this problem if our elements weren't sorted. So we want to make sure all our intervals are sorted, and then have our merge list. So the merge list initially is just going to have the first interval 0, and then we want to say for each start and end value in intervals, for each start and end value in the intervals, we want to get the last ending value, and that's going to be equal to intervals, the last element of intervals, and the element of the first index, which is going to be equal to the end value. And then we want to say if start is less than or equal to the last end, well, then we can set the last end. We don't need to add, and we don't add the interval that we are currently at. Instead, we merge these intervals together. So we say merged, the last interval, we set its end value equal to the maximum of whatever that end value is, and also the new end value of the interval that we are at. So for example, let's say we had 1, 3 and 2, 6. So let's say we have 2, 6 over here. Oh, sorry, we have 1, 3. We'll keep 1 the same, but the 3 will say what's the larger number, 6 or 3? Well, 6 is. So 1 and 6 will be our new interval. And if the elements, if the intervals don't actually overlap, well, then we can simply append them to our merged list. So we can say merged dot append start and end, and then just return our merged list. So let's submit our code here. And we get the wrong answer. Let's look at why that's happening. So we're sorting intervals. Okay, so we need to get not the last element of intervals, because that will always be static. We want to get the last element from, and the last interval from our merged list. And now we pass all 172 test cases for this problem, and we get quite an optimal solution. So in terms of time complexity, well, we are sorting the list initially. So it's going to be, time is going to be big O of n log n. There we go. And space complexity, well, space is going to be, we are putting all our elements in a new merged list, so we're reconstructing a new merged list. And worst case scenario is that there are no overlapping intervals, so that's going to be big O of n space. So that's a time and space complexity. With that being said, I hope you guys enjoyed this video, and I'll catch you in the next one.